from chapter 1. Please read that chapter now and start filling in some of the blanks now that I give you a foundational type knowledge. So good luck, and I'll see you on the discussion of the next chapter. Welcome to our discussion of Chapter 2. Chapter 2 is concerned with psychological research, and it's also known as research methods. So for those of you who have not been experienced with research, scientific research or something, a lot of the information in this chapter will be pretty new. So I highly recommend, you take your time through this process. Pause the video when you need to, take notes, and become familiar with the concepts and information. So let's proceed. So first of all, I'm just going to give you a couple of examples of, maybe questions a researcher might ask. Like take, for instance, a researcher might ask, how does television content impact children's behavior? So that is an example of one type of question that a researcher might be concerned with. I also just wanted to show you that, back in early days, some of our ancestors, they believed that trephination, which was the practice of making a hole in the skull, allowed evil spirits to leave the body, thus curing mental illness. 2 is concerned with psychological research, and it's also known as research methods. So for those of you who have not been experienced with research, scientific research or something, a lot of the information in this chapter will be pretty new. So I highly recommend, you take your time through this process. Pause the video when you need to, take notes, and become familiar with the concepts and information. So let's proceed. So first of all, I'm just going to give you a couple of examples of, maybe questions that a researcher might ask. Like take, for instance, a researcher might ask, how does television content impact children's behavior? So that is an example of one type of question that a researcher might be concerned with. I also just wanted to show you that, back in early days, some of our ancestors, they believed that trephination, which was the practice of making a hole in the skull, allowed evil spirits to leave the body, thus curing mental illness and other disorders. So just, think about that. Is that very scientific? Does that, is anything measured? Is anything recorded? It's just something to think about. Just want to make you aware of, some of the development of, I guess you could say, some of the methods that researchers used or did not use. Okay, so research, uses definitely a combination of inductive and deductive reasoning. So inductive is basically the process of beginning with, one general thing, like a hypothesis, and then from that, actually reasoning to empirical observations, and then possibly to, from there, deductive reasoning, etc., etc. Now, the thing is I don't wish you to memorize this as much as just become kind of familiar with this, because we will elaborate as we go further, okay? All right. So what's important is to know, you remember, the formal definition of psychology is the scientific study of mental processes and behavior. Well, remember, scientific means it uses the scientific method. And that includes, proposing a hypothesis. A hypothesis is basically maybe a broad, kind of like what you propose, what a researcher proposes is going to happen if they conduct research. So that's just a very simple definition. Just want to make you generally familiar with that. We will proceed and elaborate as we go. So definitely, hypothesis, that can lead to, then from there, once hypothesis is made, then you design a study and test the hypothesis, using research. So an example might be, let's just say a hypothesis was made, and a researcher said, basically that increased caffeine will result in decreased sleep. So then, how does the researcher proceed from there? Well, we'll design a study and test that hypothesis. So during that time, during that research right there, that's what the researcher will actually start giving certain people that are involved in the research, more caffeine, and then measuring their sleep to see if indeed, increased caffeine resulted in decreased sleep. Just keep in mind, this is just one general example, okay? I'm trying to be simple, okay? And not make things too difficult right off the bat. So then, as the researcher is performing the research, then afterwards, remember I said, that, he or she will observe, whether indeed, the increased caffeine resulted in decreased sleep in participants. And then after that, as the researcher has gathered the data and everything, then he or she may come up with a theory. And this is kind of a circular type process, but it's also a very simplified process. But I just want you to use this as to kind of introduce you to this process. So let's come up with some definitions here. So first of all, what is the scientific method? Well, that is actually a set of assumptions, attitudes, and procedures that guide researchers in creating questions to investigate, in generating evidence, and drawing conclusions. So that should sound pretty familiar at this point. This is what the process that I delineated in the previous part of the discussion. So let's move forward. So here are the steps of the scientific method. So step one, right here. So formulate a specific question that can be tested. So I use the example, like, will increased caffeine result in decreased amounts of sleep? And so that right there is a specific question. And then, so the researcher will form a hypothesis, and that's a tentative statement about the relationship between two or more variables. So the variables in this question are caffeine and sleep, because those will change. So increased caffeine, that's a variable that changes, and then sleep. It can be more or less, and that's another variable that changes. That's why they're called variables. They don't remain the same value all the time. They actually vary according to what's done. And then step 2 right here is the researcher will design a study and collect the data as the researcher proceeds. So take for instance, just using our simple example, caffeine and sleep. Well, the researcher might say, okay, this part of the group, they will receive 100 milligrams of caffeine per day, and then this part of the group will receive 300 milligrams of caffeine, this, and et cetera, 500 milligrams, 1,000 milligrams, and then measure each of their sleeps. Well, that's right there that's the steps involved in designing that study. And then, of course, the researcher will measure how much sleep each participant got. And that is called the data, the relevant data. Okay? And so let's just move forward. We don't have to memorize all this quite yet. Okay, step 3, after the researcher has collected the data, is the researcher has to analyze the data and come to conclusions. So using our example, once again, the researcher will say, oh, definitely the data shows that as caffeine is increased in an individual, they experience decreased hours of sleep or time slept well or something. Okay, then step 4 is the researcher will report the results. So that right there, the step of reporting the results, that basically right there, here's a bunch of things. I'm not going to read each of these, but definitely pause the video, take a look at these. But this is the kind of results that are reported in journals, in scientific and psychological journals, and written up into articles, and then those get published by the journals.
New account offer. Get 65 cents per gallon in fuel discounts with a new Techron Advantage card for the first 30 days on new accounts open April 1st through September 30th, 2025.
Okay, and those are the steps of the scientific method. So on this frame right here, I highly recommend that you definitely pause the video and take very good notes on this. These right here are the scientific terms that you will have to be fairly familiar with. Okay, especially a hypothesis, a variable. The operational definition, that just means how the variables in a study will be manipulated or measured. So take for instance, using our example, caffeine and the effects on sleep. Well, how much caffeine and how much sleep each individual got, and those will actually result in what's called the operational definition. So that is basically how the design was studied. That's all there is to that. That's a simple way to think of it. Now, usually statistics refer to the type of math that is used by researchers to organize, summarize, and interpret their data or their data, however you want to pronounce it. I say data, but either is fine. Okay? Now, statistically significant, that's just another, it's another math figure, a mathematical indication that tells, how likely the results may have occurred by chance or may have not occurred by chance. So the more statistically significant results were, then the less likely that they would have occurred by chance. And so you'll hear researchers say that quite often. They'll say, well, I found this to be very significant or statistically significant, which means that's good news. Okay. A meta-analysis, all that means is taking the data all the results, data results from a multitude of studies, many research studies, as it's written right here, on one topic, putting all that data together, all of the statistics together, and coming up with one big statistic. So that is called meta-analysis. Now, last but not least is the term replicate. Replicate means basically to repeat or duplicate a study exactly in order to increase confidence in the validity of the findings. So what's really important is that most studies, especially in science, studies usually have to be what's called replicated. And that means by a variety of researchers and a variety of participants, probably through, if not the country, throughout the world, in order to measure and see how close results were for each researcher to the original findings. So that's what's called replicate or replication. So let's move forward and clear your head there a little bit. So here's a couple more terms here. So theory. So a theory is an explanation, a tentative explanation that tries to integrate and account for the relationship of various findings. Now you see right there, I put this right here in this type of font because various findings and observations. So I will give you an example that has nothing to do with psychology so much, but this is something that most of us have heard of, and that is the Big Bang Theory. Okay, so the Big Bang Theory is actually the result of many findings in many disciplines. So, like take for instance, definitely, all the different facets of science, all kinds of things. So I hope that makes sense to you. Elaborate too much more on that. So let's move forward here. So pseudoscience, what is pseudoscience? So a pseudoscience, that is usually a theory, method, or practice that promotes claims, and even though they're not supported by empirical evidence, is lacking or non-existent. So pseudo basically means false or fake. So that's the kind of theories that are, proposed, but they're not based on science. And those can be found, especially, on a lot of social media these days and things like that. People are making claims about certain things that they believe in or, heard on social media, but they're actually not real scientific claims. So I just put here, can you think of some examples of pseudoscience? Might be something, you might want to put in our discussions, our chapter discussions or something. All right. Okay, so another type of research method is called naturalistic observation. Okay, so naturalistic, that just means watching people or animals in their natural habitats. So detecting, they look at the behavior of people in their natural habitat without stepping in and actually doing an experiment. So a good example is, like, say a researcher is studying violence, but more specifically, maybe violence at sporting events, and even more specifically, maybe not so much the athletes, but the people watching the games or something. So they may actually just go and observe and record behavior and collect data that way, and that's called naturalistic observation. That's just one example, though, so just want you to keep that in mind.
Do you understand my English, but you can't speak like me? Don't give up. Try this.
So, I put an example here too, those of you who know who Jane Goodall is, made a career doing naturalistic observations of chimpanzees. So that's another good example. She would just sit, and observe and record and get to know, basically the behaviors of chimpanzees. But she would do it in a naturalistic way. She wouldn't interfere. She would just stay out of the scene and just observe. Okay. All right, another term to be familiar with is what's known as a case study. So this is very, very simple. All a case study is a description, a highly detailed description of a single individual. That means one person. And so a case study can be, I put in some notes here, so definitely read these on your own. But it can be useful in clinical, neurological, and neuroscientific areas. Take, for instance, if a person is having issues and a neuroscientist wants to conduct a brain scan, such as an MRI or something, that right there is a specific study only on that one individual. So that is a case study. Now, survey, most of you probably are familiar with what a survey is and maybe even participated in some. Basically asking people their opinions, maybe behaviors, that sort of thing. I definitely pause the video here and look at this a little quicker, and I give you an example of a survey. Here's an example. Take for instance, your opinion is important to us, and would you like to participate? And then you can click yes or no, etc., etc. And then that way you're telling these people your opinions and behaviors, according to the questions and what you feel comfortable answering. So that's an example of a survey. Now, another type of research is archival research. Right here, I put that in red. That's basically just examining records, whether they're hard copy or whether they're electronic records. So that's another form of research, believe it or not. Now, another term here is what's known as longitudinal research. That is this term right here in red, longitudinal. That means basically over a period of time. So researchers might want to understand, what are the effects of smoking? Well, they can't just conduct research and only check with a person one time and say, well, our data that we covered, was only on a specific date and this amount of persons. So what they will do is over a long period of time, they may, using longitudinal research, use that term again, to help that kind of hammer that into your minds here. But an example might be following and collecting data with a group of persons, they're involved in the research, maybe over 10 years or 20 years, and measuring their health and how it changes while they smoke, that kind of thing. So that's just an example there. Now, often correlation, right here, correlation is this term, and that basically is concerned more with how strongly related two factors are to each other. So take for instance, I'm just going to make up a really funny, strange correlation. But researchers might say, look, foot size has been shown to correlate with IQ measurement. So then they'll say people with bigger feet, you know, are, have been shown to correlate with higher levels of intelligence or something. Now, of course, you know, that's not true, but I'm just making that up, you know, off the top of my head just to be kind of funny or whatever. But basically, they're not saying that correlation, let me rephrase that. Correlation is not concerned with saying that something causes something else. They're not going to say, well, you know, big feet cause higher intelligence. But they may say, but our research has shown that larger feet, you know, are correlated with higher IQ scores or something of that nature. But they're not saying that it causes it. They're just saying that those two factors are correlated to each other. Okay? And then usually correlation, that also is usually shown in a number. And believe it or not, usually that number is just between, like, say, -1 to +1. And that right there, the closer it is to 1 or a -1, then the stronger the correlation is. And then if it's 0 right in the middle, then that means there's no correlation at all. So a positive correlation is right here, and please pause the video here and take notes and make yourself familiar with this, you know, if you need to. But a positive correlation.
Oh, Anthony Babauta. Well, hello. Are you still here? Hold on. Oh, hey.